Right.
Hey, got it. Okay.
Hey, there we go.
Hey there, I'm Samantha from Marie 3D. I'm here today in our Austin factory, and today's a really cool fused granular fabrication user group meeting because I believe this is our first speaker from the UK. So as we make our way around the globe, we're looking forward to hearing from him. It's a little late his time, so we appreciate him making space to share. But today we're going to be speaking with Aaron Hooper, who is a self-taught technician and engineer. He's a jack of all trades and has many skill sets. He has a background both in as an experienced mechanic, electrical, fabrication, and basic CAD design. He's been working for over 20 years now as a contractor with MOD, aerospace, pharmaceutical, nuclear, rail, and R&D. So truly has a lot of perspective across many industries. We met him as an intro from our speaker last month, which has been really cool to see the community propagate. And he came highly recommended because he has a passion for LFAM and has built his own pellet extruder. So it's, I think for those of us in the industry, it's gonna be really refreshing because he's passionate about this as a hobby. Is looking forward to making some mods over Christmas, but also just drawing into his domain expertise and the many collaborations that he has. So with that in mind, I'm going to go ahead and turn it over to Aaron to present. Just as a reminder, this portion is being recorded, but if you have questions, we'll go ahead and open it up at the end for you to jump in during the recording, and then we'll turn it off if you prefer to network off the recording. If you jump in late or have to jump off, we're going to go ahead and post this to that FGF User Group playlist on YouTube, and so you can feel free to share it with your peers and listen to it again later. But Aaron, I will let you take over.
Thank you very much. Hi everyone. As you said, I'm Aaron Hooper. I've got a major passion for large additive manufacturing because, well, why not? Because you've got to have a hobby nowadays. Like I said, the background, 20 years contracting, all sectors, ex-MOD, and I love to get my hands dirty. If it's interesting, I'll learn it. Simple as that. I started probably about 5 years now. I bought my first system, little Tronxy X5 SA. Immediately, within a month, decided new rails needed, new control system needed, new extruder needed. Went straight all in, and lucky for me, Duet just come out with their freeboard, so I got that. E3D just come out of their Hemera and their Super Volcano, jumped straight on that, and then high wing rails across the whole system. And then got really into that, driving my family absolutely crazy because the printer was constantly going for testing, as you do. And then decided the following year, you know what, I want to build my own printer from scratch, and proceeded from there to from the ground up to build myself a 3 meter by 2 meter hybrid system. And a hybrid system, if you don't know, is a mix between between extrusion, so additive, and subtractive. So my system has a spindle. Not I use it very much because it's just too loud for me. So definitely a fun piece of kit to use, but it does ring when you're in a small space like I work on. I predominantly use PETG. It's a regrind from a local, well, it was from a local supplier. Unfortunately, it was a family-run business and had to close recently. So luckily, I've got some good contacts. So I've had to been able to source some good materials for additional testing. So that's quite fortunate, is the way to put it. I've got a simple layout with regards to the presentations, which way you put it. Probably not the format everyone's used to, so I do apologise. It's probably not professional. So just going through some general bits and pieces with regards to um, my system itself alone. We'll go through and regards to what the potential futures are for LFAM itself and limitations and how we can maybe get around them. And as most people probably know here, if you don't, pellet extrusion systems, you come in an open variety of materials, which is much more beneficial than using your filament based limitations with regards to compositions. I said I use PTG. I've done HDP, I wouldn't advise it unless you have a mechanical locking system, which is just a glorified way of seeing screws and big washers to lock the material down because it has a like 5 to 10% shrinkage. And when you're printing a large object, you do get major warping, and it's quite hard to fight without a rigid system itself. Polypropylene is a lot easier, but still not easy to work with. I think that's probably why I fell in love with PETG and PET because it I just put it on an MDF board, a moisture resistant MDF board specifically with wood glue. I use, what is it called? Gorilla Glue. Works great to put a layer down. If anything, it's probably too good because sometimes it takes a bit of my board with it and I have to replace the board on a infrequent basis. But it comes out great. Just watching the beads go down is a bit hypnotic, as anyone probably you all know yourself. I have to step away sometimes to try and get some work done without keep watching it all the time. The system itself is, like I said, 3 meters by 2 meter frame, all on high winds, on a gantry system, and on a four-stage telescoping arm, which I built. Tried dialing in a telescopic arm when you've only got an angle grinder. It's quite fun, and a file. So a lot of measurements, a lot of taping, a lot of adjustment to get that in. That runs on belts, so it's kind of like a glorified forklift system, but it's handy because the system will expand as much as 1.8 meters, but it fully collapses to 800 mil, which means it's a lot more efficient with regards to space because I've only got a max height of about 2.2 meters in my workshop, but I can still, with that, I can still get about 1.4 in the Z height, which is very convenient. And then the actual the working area itself is 2.4 meters by 1.2 on the X and 1.4 on the Z. So I've got quite big extrusion area to play with, which is really nice. My pellet extruder itself is botched together between JBL servos and a robot dig, if anyone's heard of robot dig, the pellet extruder. Considering I inquired in England about getting a pellet extruder itself, I was quoted about, I think, between 2 and 6,000 for the barrel and 6 and 12,000 for the screw for a 2 kilo output system. And that was just hardware. That was not servos, planetary gearbox, hoppers, nothing else. So I went, you know what? We'll look online, robot dig, £220. I bought two. So brilliant. And then just a 440-watt servo motor with a 80-to-1 planetary gearbox. And then the hopper itself, you just kind of 3D print. That's nylon carbon fiber. Worked really well. And then to convey the material, the flakes themselves was, as you're saying, a independent auger with a vibrating motor on the hopper on the feed, just to make sure everything's constantly flowing in the head to allow yourself to have a consistent extrusion rate without any gaps. If you probably notice, even on some of the industrial stuff, if you look at their prints and their prints come out, you'll see a void sometimes. It's because their hoppers had a jam, basically, or the feed system's jammed in. So it's something you always want to monitor. So having a high frequency vibration, so not heavy, because you don't want to rattle the system, do you? Just to keep everything kind of fluid, so to speak. And then I've adapted the system multiple times, keep adapting the system multiple times because we like to play and add. So now I have a system that I can do my own colors in a controlled form. On a dose, I have two dosage metering systems installed on it, which means I can change my colors as and when I want with a short transition period. So it opens up the realm for a bit more creativity, which is quite nice. I also have my own design for a foaming system. So I can foam my material on the fly and then basically hopefully reduce the amount of material that I'm using based on volume. So far, I've got about 4-to-1 ratio on weight to volume, which is pretty good. So given the materials you might be using, obviously you want to make sure your thermal properties are right within that realm of what you're using your foam. but you can make, I mean, I'm thinking about with regards to light structures, lightweight, large, lightweight light structures, diffusers and things like that. I do have an obsession with lighting because I think lighting creates the mood for everywhere, doesn't it? If you got beautiful lighting, it kind of sets the mood in an environment. So the idea for the system is to have a variable intelligent composition extrusion system. So the system itself will eventually be expanded for additives, for all additive ranges, fillers, even to the extent of going down to metals. So I'll be able to use say a polypropylene for a binding material, and then just do a ratio of metal to do a cold print, and then sinter afterwards. But that allow for a lot of metallurgy, yeah, in the science side of things. But that's beyond my mental capabilities right now. That's something I need to learn later down the line. But on the other stuff, it's capable of adding, we said the pigments, your additives, UV stabilizers, thicknesses. So if you get a recycled material, for example, but the material was injection molded, you aren't going to be able to use it on a normal standard pellet extruder because it's just gonna flow out. So you can add some additives to make that viscosity, to increase the viscosity. Because when you are printing itself, you need to make sure your temperatures, especially on LFAM, on large stuff, your temperatures are high enough for the material to melt and flow nicely, but also high enough for the layers to bond. Because if you have the temperature too low, your layers won't bond very well. It won't have enough time to bond very well. Because where you're going for your tool path, and your tool path's a lot longer than what your standard FFF would be, and you're only running that maximum. I mean, if you're pushing it, if you're doing 100 millimeters a second, going way too fast. So I mean, I range around 15 to maybe 25 if I'm feeling lucky, or it's a very short tool path. And you want to make sure that that layer below is still of a decent temperature to ensure the next layer above has got good adhesion. So there's a lot to think about with regards to your pellet-based extrusion system. It's not as simple as going from your filament straight to pellets. There's a lot more to think about. You've got a lot more thermal capacity in the material itself when you're doing your extrusion. You can't overhangs, not going to happen. Not unless you can get a 45 degree print in the go there. I mean, I am working on. I've done an adjustable nozzle the other month that fully adjusts between 0 and 45 degrees, and it was working really well. And then my temperature went up and my flow increased, and it started to ooze out the areas. I didn't want it to ooze, unfortunately. So back to the drawing board on that, but it looked promising. So I could literally go from 0 to 45 and back again automatically, which means the tool paths could be quite interesting from a 45 degree print. And then on the top to do a 0 degree print straight over the top, which would mean you can have a lot more intricacy with regards to the printing without having to use a 6-axis system. And then also on top of that is the next step is the adjustable nozzle system, which is going to be a lot more intricate, which is going to be fun. But that's definitely 2026 down the line. So we go through I do apologize here. I jumped too far. So we've got some things with
Hey,
regards to. Oh, go ahead.
Aaron, quick question. Were you sharing your screen or were you trying to? Because we only saw you.
No, no, sorry. I was just kind of
Okay,
flicking. I was trying to flick through. I'm trying to do
just
both at the
checking.
same time. I'm not used to this.
Oh, yeah, no worries.
I should have done cue cards. It would have been good for me. I could just flick through them underneath my hands.
I just want to
So,
make sure we weren't missing anything. I know I'll want to see a picture at some point.
um, I've all stuff I've got is uploaded on my LinkedIn profile.
Oh, good. I'll put that in the link to the
Yeah,
chat then.
everything and
Yeah.
anything I do, I always put up on my LinkedIn profile. Obviously, within
Okay.
reason, I can't show the full
Yeah, yeah.
extrusion system I've got right now, but the baselines of the system itself are on there from when I started off from the ground up to when I've built it.
Oh, perfect. I'll
If
stick
anyone
that in
wants,
while you keep chatting then.
yeah, if anyone wants breakdown on materials on there as well, they're more than welcome to DM me and I can send them over what I've been using, what ratios, a gearbox. So the system itself even runs on Kevlar belts. Um, I should probably upgrade that to a linear, or maybe pinion, rack and pinion probably be better for that size, because if I use a ball screw, I know I'm just going to get whip for that sort of 3 meter range. It's not viable. The gantry itself probably weighs about 200 kilos, so I'm surprised the belts do as well as they do. It's quite rigid. Um, so I've kind of gone on to my, where were we? Toolpaths regions. So go to go to brain's gone dead. We'll go to the extrusion system that I'm proposing is the with regards to the smart material systems. So when you when you print, do apologize, my words are evading me right now. When you're printing, you're locked into one material when you're printing with pellets. You've seen some companies, you'll see a multicolor system, but it's not controllable. So what they'll do is they'll put a bit of pigment in here and there. I seen one the other month. It's not Caracol, was it Wasp, I believe, have got a color system. And what they do is they have in the hopper, they have a little cutter that cuts pigment into the hopper. So unless you know exactly the volume of material that's in the hopper and in the barrel, you're not going to get that control with regards to where you want this color to go, what layer you want it to go. You're just kind of still kind of poking around in the dark a little bit and hoping it within that range. But with the short transition that I've worked on, I've got static and active mixing system to ensure, obviously, it's homogeneous. Is probably the best word for it. The mix is good, but then also the transition period is short as you can get it. And this enables you that if you're doing larger prints, for example, enables you to have regional control. So if you're doing a large print and you want your corners to be stiffened, you can introduce glass fiber, carbon fiber, wood powder, whichever one you want to use to enforce that corner. But then if you want your main rib, your main expanse between them corners to be more impact resistant, you can just use your main material or you just add an elastomer all at the same time. But you can do this per layer in that singular layer as well. So it enables you to create a intelligent structure, so to speak. There's no better way of putting it. It's like anything in nature. Everything is made from generally the same base product, but it has a variable compositions within that product, within that material. And this allows you to just create regions of reinforcement or thermal capabilities or UV stabilizers or whichever way you want, or in the artistic side of things, color. You could add a nice tweak of patterns within that Z-axis instead of just within the XY layer. So you could create a logo or whatever you want in that Z as well, which is just makes it much more capabilities of it. You could, I don't know, I can't think of the best word for it without sounding really sappy. It's just more beautiful. That's it. You just create a much more beautiful product, and on the engineering side of things, you create something that's a lot more viable for actual use. I mean, with a foaming side of things, you can reduce your material usage by 5-10-fold, but still have enough rigidity within that material to give yourself say for a tooling, for example, give your top layer enough rigidity on there to hold that material so it overhangs, compensate for your overhangs, and keeping your material waste absolute to the minimum. When you're doing automation, you're printing, most companies print in a one core material, but they have variants of that same core material. You don't need that. You just have that one core material. So whatever recycled bulk material we've got in, that's your feedstock. You don't need any variant of it. You change and modify it as you want, as you need on the fly. So in a production side, completely hands-free, as humanless as possible, like as we're all trying to seem to be getting, you can have a conveyor system that would go down, do a red chair, next one's a green chair, next one's a blue chair, next one's a whatever, next one's a carbon fiber chair, or, but you don't have to change your main feedstock. So you can just keep rolling along in a complete autonomous line without having to the purge is minimal, so your waste is drastically reduced. You've seen companies with the you're looking at 40 kilo an hour extrusion systems when they've changed just not even not the material itself. So say it's the same polypropylene, for example, they just changed the color. They've purged out 10 plus kilos of material just to get to the next color. That's a lot of waste. And once that's cycled around so many times, I mean, over the year, they've probably wasted a ton of material, and you break that down to more and more and more of us that are doing this, the more and more waste we're getting just based on that process alone, where we're supposed to be making the best use of the recycled material or the virgin material or a mix of both together. So, because depending on what you're using it from, you can't always just use recycled material because it needs to have certain minimal properties. You have to sometimes use this recycled material to water down the virgin material to bring it up to that level as well. So it just opens up. I probably can't explain it well enough because I originally designed it because when I was doing my prints, I noticed that I'm just printing this one color. I want more. And then that's when it kind of expanded onto that. I wanted to do more. So at the beginning of this year, I just decided, you know what, I need to change this. This needs to be a bit more interesting now. The limitations that you watch, as much as I love watching the LFAM seed, extrusion, you got what's the ones? Haddy. Is it Haddy? Over your way, does all the furniture. Yes, Haddy. Absolutely love just watching, just looking at their factory, but it's all a generic color, you know, because even with our recycling facilities here, um, one guy I work with, they have to just use a carbon black because they get all this varied of color of material, and everything has to go carbon black. It just seems such a waste. There's no volume for sorting for these colors to be broken down and segregated. They all just chucked into one big vat, carbon black, that's it. And I was like, oh, that's such a shame, such a waste of potential there. So back to it. Sorry, I do deviate a lot. My mind kind of just drifts off a little bit. I do apologize. So within this realm, you've got to consider that obviously we want software to coexist with this. So I use the AI build system at the moment. And then also I adapt my G code. At the moment, it's quite painful because as you can imagine, you go through, get your G code viewer. Oh, I can change that. Scroll through 1,000,001 bits of code just to put one tool change in. So we need to slowly build on that. But as the time goes on with it, the AI systems itself, and I know it's a trend word right now, and I'm not using it because of that, are getting that clever that you can give them a database simulation. So once the AI systems have gotten to, and probably already are there that we don't know yet, have gotten to a level that they know this material, with this additive, based on this rate, based on this temperature, this is the result that you'll be able to input or throw at it your model and say, right, it needs to handle this temperature in this region, needs to handle this these forces in XYZ dimensions. It also needs to be within this weight limit. And all you got to do is say, right, I've got these materials and these additives that I can use, design me a toolpath, and it will do all that for you. And it will just spit out this variable, like I said, word composition toolpath. And then my system will enable it to bring it to life. So you're working between the digital side of things, digital simulation, into real world use cases. I mean, that AI side of things is that it is probably already there. I probably just need to get my feelers out there, try and find the people that will help me bring that to life, and then assist me with getting the jerry rig DIY extruder that I have at the moment to a more professional manner. But we're testing out some new material, hopefully in the next couple of weeks, which is the textiles, I was saying to you earlier, textiles based material, from polyester shirts, t-shirts, and they're going to see if we can produce a nice little line of furniture and or lighting or both. And then hopefully, so in the new year, hopefully have something I can kind of post up and start getting getting people to realize that, this can be done, and it can be done. You don't have to have a degree. You don't have to, you just have to have a passion to learn stuff. That's it. Everything I've learned has been um, gen- people like yourself have put out, your videos. This is how I did this. This is how I did that. Try it, you know. But since 3D printing, price of 3D printing come down, I mean, the only reason I could afford the printer that I bought originally, the Tronxy, was the prices come down. That's what opens up for everyone to be able to adapt, change, advance. I mean, 3D printing itself has been around since the 80s, but it's only advanced the most in the last 10 years because everyone's gotten involved. The more minds, the more brains, the more hands-on, the more creativity added to it. Half the stuff out there is open source. When you got these companies that certain names we all probably know have patents for, heated chambers, glorified oven, but they've managed to get away with that and holding it to ransom for years and years and years. Now the floodgates are open, everyone's straight back on it again, which is fantastic. We've had such a development though in the last few years, and that's why with the pellet-based system, I didn't want to buy generic off the shelf. I wanted to learn from the ground up. So I managed to do all the hybrid side of things. I think at the stage, I'm not trying to give myself a thing here. I think at the stage when I built it, it's probably the largest DIY hybrid printer anywhere because I just, some strange reason, it's like go big or go home. So I went from a 300 by 300 printer to a 3 meter by 2 meter frame. A little bit drastic, but got to do it because what we were saying earlier, there is a big difference between filament printing and pellet printing. There's so much more to think about. You just need to consider that it takes time for that material to cool. If you consider that the whole time, you can't go much wrong really with regards to printing that because know that you need to go slow. This, and test and play. That's it really. I mean, I spent weeks, years, weekends. I've got a camp bed in my workshop with a sleeping bag. So if I feel like I've had a long day and I need a nap, I can just have a nap where I am. But that's just me. I mean, not everyone's like that. I know some people will go all out and do a 100-hour week. And I get that for a passion. You're quite happy to do a 24-hour stint. I had one where I'd done a print for a gentleman. He needed tooling for a brass hammer tooling, and it took 12 hours to print. And silly me I still haven't done it now actually, fitted my auto feed system. So for 11, 12 hours in the workshop, I was feeding the printer manually the whole time. It was almost drifting off. Come 10 hours into it, I was almost falling asleep. And I knew if I fell asleep, that print was going to fail. So I pretty much lived off Red Bull for that entire day. Red Bull and pot noodles, anything quick just to keep me going. Um, but how are we doing for time there? Probably rattled on quite a bit.
Oh, this is fabulous. I know I have a couple of questions, if you don't mind. I bet some other participants do too. And then if anyone didn't see it, I put the Aaron's LinkedIn in the chat. He has a YouTube as well. You'll see in there, so you can get a little taste of what he's doing. But yeah, does anyone have any questions while the recording's on for Aaron? And then I might share a couple as well.
I'll try and answer the best I can.
I have a quick question about your pellet printer. I'm
Yeah, go
actually
ahead.
looking at some of the short videos on your YouTube channel right now. Do you have a part cooling solution for your extruders?
I was using some 50 mil 24-volt fans originally,
Okay.
which I found worked pretty good. It's two fans pointing pretty much directly at the nozzle. Because you do require, if you're going to try cooling, you need a lot of flow.
Hmm.
Definitely a lot of flow. But there are 50 mil fans that I got off Amazon. Strange enough, yeah.
Oh.
Amazon's fantastic. I love Amazon. That was not a promotion.
Do you ever find that when you're working with materials that warp and shrink, part cooling can actually harm the quality by any chance?
If you keep your temperatures within a range, you need to play with your temperatures on your extrusion.
Hmm.
So keep your temperatures as low as you can get away with to ensure you still get good layer adhesion and flow. Because that way you reduce the amount of shrinkage. So the more heat you put in, obviously the more material expands. So the more shrinkage you're going to get,
Hmm.
especially when you're, I mean, like my nozzle on my print at the moment is 5 millimeters. So you think based on that volume, there's a lot of heat going in there. Um, and the higher the temperature, I found, especially even with, I got away a few times with HDPE reducing the shrinkage without having to fill the
Hmm.
material. Because most companies, they fill the material with like glass fiber powder or wood, which does pretty much almost eliminate your warping. But if you're using pure material, you just need to play with your temperatures more
Okay,
and
I see.
just go from there.
Thanks.
No problem.
Heating bands do you have?
I use at the moment one, two, three. So I have three 500 watts if I need it. I don't use them at full chat. I have one just below the hopper if I needed to introduce just some sort of additional heating for flow, depending on the material. And then I also have two cartridge heaters within my little mixing head as well, just to kind of
Mm.
because of the shape, you can't always use a band. But in my case, I mean, most people it's just a straightforward barrel, so heating bands are fine. But I use microcoils, which is a company over here in the UK which make custom ones, which are basically like the equivalent of hot runners. I don't use ceramic ones, and I don't use brass heaters. I use basically it's a formed hot runner heating element, which I find a lot more efficient, and it just has a brass insert to distribute the heat better. And they work great. I've had them on there for years. They're absolutely amazing.
That's super cool. And for the screw that you selected, it has a mixing element?
I no, I have my own. So the screw itself is Robot Dig standard one. It's a 20 millimeter screw. I think it's a 20 to 28 to 1 LD. But
Understood.
the rest of it is all been basically makeshift from my little manual lathe and like I said, a grinder and a welder to all the other stuff. And then my other mixer I had 3D printed out of stainless steel from PCBWay, which works. Consider it's a what do you call it? It was not an engineered part. It was a that looks right, that should work part. It works okay. We never know till you
That's-
try.
And how do you slice? You mentioned that you go through the command and make the adjustments as needed. What slicer do you use?
At this moment, I'm for the big print. I'm just using Cura,
Okay.
and then what I do is I'll do a base toolpath with no tools in there because Cura can't do what I want
Mhm.
in a Cura doesn't allow you to do a tool change when you're doing spiral because that's how I test my toolpaths better. The transition
Mhm.
period, just do a spiral print. So while it's flowing, I can change it and then I can work out what my adaptations need to be. So, but Cura doesn't let you do that. So I have to go in manually and just type it all manually. Which is not too bad. T1, T2, T3, or whichever I need to do. And then I'll just go into a G-code viewer to make sure I get the transition where I need it.
Super cool. Does anyone else have any questions for Aaron?
Yeah, I am hi Aaron, I'm Mike.
Hello,
Um
Mike.
I'm a little curious on print surface.
Yeah.
What type of print surfaces do you typically go for? Like
For the,
textured or what materials?
no, it's just a standard moisture resistant MDF board.
Hmm.
Because MDF doesn't, I mean, any like wood material itself doesn't pull the heat out of the material either. So it's a great insulator because I use just a cold bed. It's not even a heated bed. And then I just put a layer of wood glue down as well. And the
Nice.
PETG just sticks like crazy to it.
Cool. Thanks.
No problem.
I'm curious, you mentioned as you're working with the polyester textiles that you're looking at making some large furniture. What are you going to call the collection?
I um, I was toying around the idea of rags to something earlier on today because that's exactly what it is. Rags to use or something along
I
that
like
line.
the
Yeah, I was thinking, I mean, obviously that rags to riches coming up for it, that just sounds really self-glorified. But rags to use or, I think rags to furniture just doesn't quite have the same. It's got to be an R and R,
Mm-mm.
isn't it? Um, but we're gonna toy around with that a little
Yeah.
bit. I mean, my company itself is Protean AM, which I obviously forgot to mention, and that's I only started that up in September. On my main profile, it's Asset Technologies, which was the company limited company I used as a contractor. So for like the rail work and all the other stuff that I do on my normal 9 to 5, Monday to Friday, that's what I use that for. But that's what's on my LinkedIn profile. I haven't even expanded on the Protein AM on my LinkedIn yet. So it's relatively new. And the Protein is predominantly, if if anyone knows what the word means, is like look into the horizon, look into creativity, opening, not thinking just stagnantly, always thinking ahead. Um, and that's the whole point of things, isn't it? I mean, 3D print itself has opened up the realms of so many people with regards to creativity. You couldn't manufacture in your household not that long ago. You couldn't manufacture anything in your household, whereas now all these little 3D printers coming out with color change systems and things like that, they're absolutely astounding now. We just need to get pellets based systems in the houses and kill filament. That's what we need to do. Sorry, that's my dog Lexi going off on one.
Does anyone else have any, Mike agrees. Does anyone else have any questions for Aaron while the recording's on? Otherwise, I'll go ahead and turn it off. Okay, well, I'm going to go ahead and turn the recording off, but know that if you have a friend or a peer or yourself want to share in a future month, please let us know. We're always looking for suggestions as we're trying to build this community as pioneers together. So I'm going to go ahead and pretend to stop the recording.